Welcome to Learning Machines seminars at RISE. Today it's my pleasure to introduce my colleague, Aleksis Pirinen. Aleksis defended his PhD in 2021 at Lund University. He's been working on reinforcement learning for computer vision tasks and joined RISE last year. And he's now working on deep learning for climate adaptation, among other things. And the title of today's talk is AI and climate change. So please, Aleksis, the floor is yours.
Okay, thank you, Olof, for that introduction. Yes, welcome everyone. So I should begin by saying that today's presentation will not be focused on particular AI models or architectures for certain specific tasks or so, but it's rather going to be about presenting various directions for this type of research and various considerations as we move along. So I hope to at least raise some interesting topics for discussion and so on. So let's get started then. So as we've all witnessed, climate change is increasingly affecting many parts of the world. Sort of natural disasters seem to be happening everywhere. So climate change has gone from something distant, both sort of spatially and temporally, at least for some of us, to something which is here now and everywhere, to varying degrees, obviously, but again, it can happen anywhere now. But on the other hand, with more and more weather disasters, etc., that also means that there's more data and a potential to learn and be able to better prepare for future events in climate change. So that is one of the potentials for AI to be able to predict certain weather disasters, etc., as we will see. When you talk about mitigating climate change, you typically categorize it into a few main categories. And these are climate mitigation, which is about reducing the amount of carbon emissions that gets emitted, reducing the amount of heating that we experience, essentially. And that can be all sorts of things, such as, for example, improving energy systems or sort of doing some sort of predictions of traffic so that there's less traffic jams and all sorts of things that could lead to less emissions. On the other hand, we also have climate adaptation, which, as it sounds, is about adapting to the effects of climate change, both present climate change and increasingly difficult climate change. And then there's also a third category, which some people might say is rather adaptation, but I list it separately as geoengineering. It's about various approaches to essentially either draw down carbon emissions or to artificially cool the planet. For example, by spraying essentially aerosols in the atmosphere would be one approach to reflect sunlight and thus cool the planet. It's a controversial topic, but probably one that we will see more discussions about in the years to come. But I won't be going over geoengineering in this presentation. So for those who are interested in applying AI for climate change mitigation and so on, the main place nowadays is Climate Change AI, or CCAI, which is a sort of a non-profit organization, if you will, that arranges annual workshops at top AI conferences such as NeurIPS and ICML. And there are also other similar sort of conferences showing up nowadays. But this would be probably the main one. And it has followed from a paper called Tackling Climate Change with Machine Learning. And I will begin today's presentation with mentioning some of the main sort of recommendations from that paper. So let's get started with that. So the paper goes over different sectors in society that one could use AI to mitigate and adapt to climate change. I will mention a few of these here. More are obviously in the paper. But if we begin with the energy and sort of electricity sector, there are many sort of potential avenues here. One would be to use AI to do all sorts of predictions of, for example, when you're planning to put solar panels in certain parts, you might be able to predict optimal places for them, as well as sort of how to position them so that you maximize the amount of sun that gets to your solar panels and getting more energy. Similar things can also be done for other renewable energy sources. So AI is also being used to accelerate different types of science by sort of improving the speed at which you can do experimentation, essentially. And one such avenue could be to look into fusion science, which would be one energy source that at least some people are hoping that we will solve fusion, and AI could potentially help accelerate that direction. There's also potential for different types of forecasts when it comes to the demand. So depending on the time of the year, time of day, etc., one could use predictive models to sort of optimize the use of the energy grid, essentially. Another important sector is transportation. And here there are many possibilities. For example, you could imagine when you're driving a car, for example, and you have a GPS, this system could sort of predict routes in the city that are somewhat causing less emissions, for example, so that you don't get stuck in queues and so on. And there are some companies, I think, that are already proposing this. Other types of similar forecasts can be done for example, to optimize these sort of shared transportations like bike share rebalancing and so on. Another thing is that there's a lot of research being done on self-driving vehicles, and I mean, many people who believe that we will one day have these self-driving vehicles in cities, sort of fully autonomous fleets. One argument for this is also that that might reduce the amount of vehicles on the roads, because there could be much more potential for sharing vehicles and so on, and that could also result in less space needed for parking lots, etc. So what I'm saying here is that to that extent, you can even consider sort of research into self-driving vehicles as something which could potentially lead to climate mitigation. Land use is also a big source of emissions, and there are different ways to mitigate this. One avenue is precision agriculture, where, for example, you could use drones or other autonomous systems to analyze sort of crops, etc., on a fine level, and this type of practice could result in less sort of disruptive farming practices. There's also the possibility to use satellites and similar for sensing emissions. That is to essentially see from space where do we have emissions from, so that we can then try to reduce such emissions. And on the adaptation side, there are many different angles. Some of them include getting prepared for more and more natural disasters and other crises. So there are more and more data sets, for example, that are related to large-scale image sets that have annotated different types of disasters and so on, so that you can have that to, for example, train models that might be useful in, let's say, humanitarian aid purposes. Monitoring food supplies and predicting food demand is also an essential thing, especially with the stresses on food supplies caused by climate change. There's also an aspect about infrastructure, in which, with more extreme weather, buildings and other infrastructure will get increasingly hurt. So there's also a need to essentially do automated maintenance of all sorts of infrastructure. And let's go over just some sample research directions that are actually going on. So, as I said, there's a lot of research on predicting optimal placement for certain types of energy sources, such as solar potential of rooftops that can be done through, for example, image segmentation methods. There's also an interest in tracking certain sustainable development goals. And this could also go beyond mere climate goals, but also other societal goals like reduce poverty and so on. And the machine learning is being used, for example, to track levels of poverty used on, for example, satellite data and other types of information. As AI researchers, we also rely to a large extent on good libraries for our research. If we work, for example, in PyTorch or TensorFlow or similar. So there are now coming also libraries that are tailored towards applications within these sciences, such as this TorchGeo for geospatial data. Another increasing interest is to combine AI with sort of classic physics-based climate models, so that those could be improved in various ways, and or that these models could be made more efficient, because as I understand it, many of these classical models are very, very heavy to simulate and compute, and AI could be used to remedy some of this. For example, to model the effects of clouds in various climate models. As I already mentioned, there's an increase in climate disasters and also other second-order consequences like conflicts and wars. So there's going to be more need for crisis management, and there are increasing research being directed towards such applications as well. And then maybe on a bit of a meta level, AI, computer vision, and so on also risk emitting carbon emissions as well, because they are often very energy-intensive systems, and especially if the electricity comes from fossil fuels, that could be something to also keep in mind, and that's also being studied. There's also more efforts towards visualizations, for example, using generative adversarial networks. So this is from a webpage called "This Climate Does Not Exist," or at least it doesn't yet. But the point here is that you can essentially write any address, and it will go to, I think, Google Street View, get that address, get some image for it, and then you can then specify which type of weather disaster you would like to apply on top of that address. So you could then go and see how would a wildfire look in your neighborhood. Another very interesting line of research is on essentially tracking on a global perspective where are emissions coming from. And that can be used for many purposes, including sort of implementing policies to reduce these emissions and to make sure that big emitters, I mean, to get a more objective perspective on how much emissions are really produced in various companies, sectors, and so on. So now I will move on a little bit to just mentioning some of the main types of data that one would consider when working with AI for climate. So the most obvious one probably is satellite images. And some considerations here is that these can be very large and they can have many types of data. And what I mean by this is, in addition from just RGB space images, you can have a lot of other types of data in the general direction of your data, including elevation maps, what type of soil, topographies, and so on. And then there's also, in many cases, the temporal aspect that you might want to consider time series of satellite images. So the message here is that it can also often be quite heavy computationally to work with this data. And then there's also clouds and other potential corruptions on the imaging itself. But there's also research on removing clouds, so that's using artificial intelligence, so that one can see essentially what's below the clouds, so to say. And then another thing is that oftentimes when you, as an AI researcher or computer vision researcher, when you do explore some deep model, you would typically pre-train it on some standard data set like ImageNet or something, and then modify it or sort of transfer it to another data set. But I mean, ImageNet is a very different type of data from satellite images, so it's kind of an obvious thing, but it might not be as easy to use such transfer to this domain from that domain. drones and other mobile data collectors. This is something which I think is particularly interesting. So satellites are great in many ways, but if you have sort of small autonomous systems, say, you can get much more high quality data, and it can also be more real time. So it can also be used, for example, in humanitarian aid or something like that. But on the other hand, there are challenges here as well, because let's say you would like to analyze some conditions of, say, some forest or some crops. Then it might be kind of expensive to use this drone. It might have a limited battery and so on. So it's not always the case that you would like to scan a large area very exhaustively with this system. So questions arise about when and where should this drone capture data, and can we combine this high quality data with satellite data to do useful inference, even if we don't have full access to the drone data. Other considerations with drones is, it might disturb some of the wild animals and so on. And then on a even more zoomed out level, maybe more policy level, is that, all technologies have downsides, and drones are also used for example, in warfare. So that's something to just keep in mind. Another source of data, which I personally haven't worked with so much, but there are people in my group who specifically look into sound. That's using sound to do all sorts of monitoring of, for example, biodiversity in a soundscape analysis. I think that sound may potentially be a sort of underused source of data compared to vision data. Some of the benefits could be, if we compare to the drone, that it might be less intrusive to the nature in which we have the microphones. And then there's also interesting to have a look at how to combine, sort of different data modalities. Like, can we have systems that use both sound and, let's say, some vision to get an even better understanding of certain situations. I already mentioned a bit earlier this interest in combining AI and classical climate models, so let's consider this a bit. This is a figure from a quite recent paper in Nature, which coined a new term, which they call neural earth system modeling. And it's about combining data-driven machine learning approaches with physics-based models. So let's just have a nutshell overview of sort of the idea here. So on the left, you have your classical models, which are great in many ways. They may be interpretable, but on the other hand, they may contain persistent error sources. They might be difficult to calibrate and be very computationally heavy. On the right side, on the other hand, you have your data-driven solutions, which can leverage large amounts of data to learn good predictive models, but they lack process knowledge and may be less interpretable. So the idea is to start to join these two worlds so that they essentially become the best of the both of them, so that they have the ability to learn from data, but at the same time that they might be less reliant on large data sets because they also have prior knowledge within them. And another thing could be that these models might be more explainable, so to say, than a pure data-driven approach. Yes. So I'll mention just some limitations and drawbacks of AI within this context of climate, the climate problem. Well, first of all, AI is not a silver bullet. AI in itself will not sort of solve the issue. It has to go with strong policy changes to all sectors of society. And it could even be that, sort of a too optimistic view on believing that this will somehow fix the problem could enable a delay as well. It's also energy intensive, as I mentioned. So a lot of the trends in AI is to go towards bigger and bigger models. If that is also associated with more emissions, then that's not a good thing. And another consideration is that with more climate destabilization, that may also lead to more blackouts and power grid failures and so on. So it's sort of a resiliency issue as well. I'll get back to that in the second part. And in general, as I already alluded to earlier, I mean, a technology is only as good as essentially the ones who use it and how you apply it. So yeah, there could be negative side effects, as I'll get back to. So concluding this part with just mentioning some examples of AI climate activities here at RISE. So there is a lot of interest in circular business models in general, as that would potentially be able to reduce the amount of waste and energy needed, etc. But there are also risks for many who want to transition towards circular business models. And there has been some projects on using AI to essentially mitigate some of these risks. One particular project was about using AI to estimate the prices of second-hand clothing. Then there's also a lot of interest at RISE in sort of agricultural areas and also how to use AI in that regard. There's also work at using AI to sort of do predictive maintenance on energy systems such as district heating plants, and also to use AI for essentially estimating the amount of water flow in inland streams based on precipitation and other factors. And with such knowledge, that could be used in the long run to improve models for flood risk estimation and so on. And then there's this Swedish Space Data Lab, which is a great resource, and I'll just quote sort of the mission statement. The Swedish Space Data Lab shall be a national resource for Swedish authorities' work with Earth observation data and development of AI-based analysis of other space data. The purpose of this project is to increase the use of data from space to develop society and industry and for the best of the globe. So it's essentially a really interesting resource for anyone who's into remote sensing and working with satellite data and so on. And then I would also like to mention a quite recent report that was written essentially to all sectors of Swedish society, including policymakers. It's about a year ago, I think, AI in the service of the climate. It was written by RISE, AI Sweden, and Stockholm Resilience Center. So just to mention a few of the results in this report, which concludes that there's a lot of potential for AI in the climate sector, but it is currently difficult to quantify the climate benefits. And then sort of there's lacking a unifying arena in which different backgrounds and expertises can naturally meet, so to say, and start collaborations. And looking at an international level, it's a bit of the same, that there's no unifying international organization that really looks at these issues from a systemic point of view as it is needed. Some suggestions would be to have clearer goals and incentives for this AI for climate research. For example, they point out that one should not really maybe always separate between pure AI research and AI for climate research, but efforts on AI for climate could also have positive effects for general AI research. And then one should ensure access to sort of good examples of innovative AI applications, as well as learning examples that those who are interested in coming into this domain, so that they can more easily get into it and learn from prior works. And also, it would be good with sort of good data collection processes, having good accessibility to such data, as well as visualization tools. And I mean, this Swedish Space Data Lab is something which is in this direction, I would say. Yeah, so that concludes this part. So I think this will be a good part to have questions if there are any.
Yeah, I have a question, if I may ask.
Yeah.
I wonder, have you written or do you have plans to write an article with these contents? Because I think this would make a very nice review article.
Okay, so you mean essentially the content of this presentation, or?
Yes.
Yeah, thanks. No, I haven't thought about that, but that's a good idea. Maybe that's something we could consider. I mean, sorry.
I would like to refer to it. It's I think it's a very nice overview.
Okay, thanks a lot. Yeah, I'll consider that, definitely.
Do you have some idea on sort of what would be the most where can we do most good with these technologies?
Yeah, that's a good question. I mean, it seems that I mean, for certain types of predictive tasks, I think machine learning can be used both for mitigation and adaptation, but at least a lot of the adaptation tasks seem very sort of well fit to put into your general AI processes in some sense. So, I mean, all types of predictive tasks, as predicting risks for droughts and floods and so on. And as I already mentioned in the introduction, that I would assume that we also start to get more data given that we have more extreme events. So let's do the best out of that at least and learn to predict better certain outcomes in the future. Any final questions before I move on? All right, so I'll move on now to the second part, which I call AI considerations under a scenario of climate-driven societal disruption and collapse. So in my view, at least, there's a bit of an elephant in the room when it comes to discussions about tackling, mitigating, and adapting to climate change. And that's true also, I think, in sort of the technological aspects to solutions and so on, which is that there's very little discussion on sort of the what-if scenario of very pessimistic trajectories. And these pessimistic trajectories may not be unlikely events. A lot of researchers are warning about catastrophic changes coming our way, as I will also come back to here. So I think it's also time to start talking about considerations in a future which is maybe not as optimistic as we often like to maybe think. So I will begin with a quote from 12 scholars, climate scholars, from about 1.5 years ago. Yet, whether it is to discourage mass fatalism or prevent the very worst of what the future threatens, those of us with this knowledge still cling on to, yes, we can. In this story, it's always 5 to midnight. It's always the last chance to prevent disaster. In contrast, collective action on climate can only grow out of complete honesty. It's time to acknowledge our collective failure to respond to climate change, identify its consequences, and accept the massive personal, local, national, and global adaptation that awaits us all. So before moving on with this presentation, I would just like to point out that even when discussing pessimistic scenarios, that does not mean one should stop working towards possible optimistic scenarios by reducing emissions, etc. Quite the contrast, that should be accelerated. But there seems to be a case now, at least I would say, that we need to have a plan B discussion, definitely, about if things don't go so well. And I hope to motivate this as we move onwards and to have discussions, obviously, in the end. So, sort of a bit of the concept of collapse. It's a process that can be described as one of increasing instability, breakdown of social order, social systems, institutions, and infrastructures, caused by a combination of numerous ecological, economical, societal, and political factors, such that, on one hand, people of that given society have increasing difficulty securing their needs, and on the other hand, the institutions of that society are increasingly unable to help them to secure those needs. So, again, it's a process. It might be a process of several decades. It could go faster, obviously, but I mean, sometimes when people hear the word collapse, they think of something that just goes in a day and stuff just stops working. That's probably not the case usually. But let's have a look at a concrete example of a quite recent societal collapse, which was that of Syria. And this example is not to say that that is how everything is, all societies would collapse or so, but it's just to make this idea, which might sound a bit abstract, to something quite concrete as we move on. So this is from a BBC article describing this. Some nations are already serving as canaries in the coal mine for the issues that may eventually pull apart more affluent ones. Syria, for example, enjoyed exceptionally high fertility rates for a time, which fueled rapid population growth. A severe drought in the late 2000s, likely made worse by human-induced climate change, combined with groundwater shortages to cripple agricultural production. That crisis left large numbers of people, especially young men, unemployed, discontent, and desperate. Many flooded into urban centers, overwhelming limited resources and services there. Pre-existing ethnic tensions increased, creating fertile grounds for violence and conflicts. On top of that, poor governance, including neoliberal policies that eliminated water subsidies in the middle of the drought, tipped the country into civil war in 2011 and sent it careening toward collapse. So the process of collapse, as described by Luke Kemp, who works with existential risk at Cambridge University, he describes it as a rapid and enduring loss of population, identity, and socioeconomic complexity. Public services crumble and disorder ensues as government loses control of its monopoly on violence. To the right, I show a sort of a forward simulation of a model which is now 50 years old. It's called World 3, was released in a book called Limits to Growth by some MIT authors. And I'm showing you this partially because I just want to break down some of the main concepts of like how can we consider the main factors of a civilization as a whole. And this is their so-called business as usual run, which is indicated by sort of an increase in a lot of areas of society, followed by sharp decline also after that sort of a collapse. So we have resources, amount of pollution in the system, the amount of global population, industrial output, and industrial output would be typically things that we measure by GDP and so on. And obviously also food, amount of food. I'm going to go over some of these just to get some concrete feeling for this. So resources, one of the main ones running our society now is fossil fuels, even though we're hoping to reduce our reliance on them, obviously, but it's still running most parts of society now. It's a whole research discipline in itself, I think, to understand sort of the risks associated with this as well, because some are warning that we will lose access to or sort of cheap energy before we can move to, let's say, renewable sources. And some are warning that, I mean, there could be sort of an energy wall ahead of us. Pollution, now we think a lot of carbon emissions, obviously. But back in 1972, climate change wasn't really thought of as much. So, but there are other types of pollution as well, such as chemical pollution, which apparently we have passed the safe limit for humanity, according to Stockholm Resilience Center about a week ago. And then also speaking about sort of climate-driven collapse, one of the main things that worry researchers and many people is the fact that food productions may fail us. And that's obviously going to cause suffering and social uprisings, etc. And this 50-year-old model, even though it's a very sort of, in some sense, a simple model, the analysis that I have heard about, you can correct me if I'm wrong if somebody knows some others, but more recent comparisons to empirical data have indicated that this business as usual run with an increase and then a decline is one of the most well aligned with what's actually happened over the last 50 years. And that doesn't obviously say that the future will follow that as well, but it's definitely, for me at least, something which is quite interesting. So why should we discuss this scenario at all? Well, first of all, it may be the most likely scenario. Many scholars are saying that it is. But I would say it's relevant even if it's considered merely a possibility among others to have this sort of plan B discussion. And now I will quote from 250 plus scholars in The Guardian about 1 year ago. So only if policymakers begin to discuss this threat of societal collapse might we begin to reduce its likelihood, speed, severity, harm to the most vulnerable, and to nature. Some armed services already see collapse as an important scenario. Surveys show many people now anticipate societal collapse, and sadly this is the experience of many communities in the global south. However, it's not well reported in the media and mostly absent from civil society and politics. Ill-informed speculations about impacts on mental health and motivation will not support serious discussion. It's time to have these difficult conversations so we can reduce our complicity in the harm and make the best of a turbulent future. So I will now scroll just through some posts and headlines merely to indicate that many people are raising the alarm about this. This is not to show a conclusive evidence that a collapse is coming, merely saying that the alarm is being raised. So for me, at least, talking about these topics is kind of a challenging thing. It's emotionally stressing even. But postponing discussion about it also removes possibilities of reducing or delaying harm and suffering. And having these discussions when many parts of the world are still in a very stable place reduces the risk of having like panic responses if it would be the case that disorder would come. So having this discussion now rather than later, I think would make more sense. And some groups are already sort of having discussions about this. At least, for example, some militaries, as pointed out in this article, that the British military prepares for a 3.5 degree hotter world. It's not saying that that's going to happen, but it's making plans for it at least, which would include, for example, thinking about possibilities to go to war, to obtain critical resources so that they can go to war in future as well. And, militaries should definitely be part of these discussions, but there should be other perspectives on it as well. Climatologists are a group of people that we would often assume would be part of such a discussion, and they should, and they are already. But at the same time, climatologists, they are expert often on certain areas, climate, biosphere, and all that. But it's not necessarily the case that all of them would be experts on the complex interaction between biosphere and society, which is the intersection at which collapse would sort of play out. So I'm showing here the top 10 risks, top 10 risks in the coming 10 years, according to World Economic Forum, the latest report, where they survey global leaders and other major thinkers and so on. And these risks, not surprisingly, include a lot of environmental risks. But there's also more on the social side, like social cohesion erosion. I'll get back to that. Infectious diseases, well, we have the pandemic, debt crisis, geoeconomic confrontation, and so on. And this becomes sort of even more complex when you start considering the interactions between all of this. So on the right side, you have the top 5 risks from that report. And then on the left side, you have certain sort of effects, as you would say, which could be youth disillusionment, state collapse, mental health deterioration, involuntary migration, debt crisis, and so on. And there's even feedback loops here because the right entities are also on the left. And this in turn is just sort of a simplification, obviously. This does not cover everything. So the point I'm trying to make is that many parts of society, not just certain groups, should be sort of having, I think, some sort of discussion around this. And as AI is such a central part of society, discussing the use of this, both benefits, but also risks in case of sort of a pessimistic development is, I think, important to have. So now I'll just brainstorm a little bit of some risks that I see. So note that these are just my own thoughts. This is just to start some sort of conversation around this. And also, many of these risks are definitely worth thinking about, even if we would go towards optimistic scenarios. And finally, I should say that I don't have solutions to these risks that I list. I think they should be discussed on policy level and so on. I cannot come with a solution here, but I just want to mention some things that could be worth thinking about. So AI-driven social media, how is that affecting sort of the conversation on climate change and other important societal topics? So the World Economic Forum talks about this social cohesion erosion as a very significant risk, which has also been increased a lot during COVID-19. And it's essentially about people's increasing, in some sense, trust in social systems, democracy, increased polarization, and so on. And this report exemplifies this by some of the sort of trajectory of Americas right now, including the attack on Capitol Hill. And one could sort of start at least discussing, is there a connection between sort of the way in which social media works, since we all have our different news feeds and different, potentially somewhat different worldviews, depending on our existing beliefs. Mass surveillance. If we think about this definition by Luke Kemp, in which governments could lose a sort of control of its monopoly on violence, it's not very difficult to imagine that some governments would want to try to maintain this power by different means, including potentially violence and also different types of surveillance systems to essentially control the population in such a development. Warfare, I already mentioned, but this is something we can expect a lot more of. Conflicts, potentially civil wars, and wars between nations as well. So what role will AI play here? I don't know, but it's interesting to think about at least. Insufficient AI resiliency. So AI requires electricity, and I'm not saying that all electricity is going to go away necessarily, and it might not happen at the same time. But if we have a trajectory towards more instability, that would certainly also result in more sort of energy crisis. And even if we consider optimistic scenarios towards a green transition, there are many that expect a lot more turbulence in the energy sector as well. So couple that with an increase towards very high computation models that require a lot of energy. It's one could at least speculate that some of these models may not be useful when you actually need them because you don't have the capacity to use it. So maybe a far off idea, but maybe we could start thinking about building very resilient computation centers so that we have access to critical AI infrastructure, even as, let's say, there are sort of energy crisis and blackouts and so on. And another thing to consider could be to maybe not think about having AI everywhere, but actually, or rather we could have AI everywhere, I guess, but at least couple it with things that are not so as brittle to energy problems and so on. So that was some risks that I would like to mention, but let's look at some possible, use cases as we move on, if we would go to a more pessimistic trajectory. So related to this resilience, more research into AI that uses low computation could be very beneficial. And there's already research here. So, I'm just saying that this is something that is relevant to keep considering, so that they don't require as much energy. And also, we have all witnessed the supply chain stresses caused in part by COVID-19. This is something we can expect to increase at least in this trajectory. So as AI researchers, we may have had a difficult time getting our hands on graphics cards, for example. But on the other hand, there seems to be some direction to use AI to manage and mitigate stresses in supply chains. So that could be something. More efforts on AI for humanitarian aid should probably be considered, as there will be more need for it as well. Even during COVID-19, the need for humanitarian aid has increased a lot. So more efforts toward that. And also gender-based violence, the way in which sort of conflicts and wars affect women, as rape is often being used as a weapon of war. So ways in which, I'm not saying that AI would solve that horrific issue, but at least there could be some considerations to mitigate some of it. Mass migration, how to deal with that. Maybe there are ways in which AI can be used to map somewhat more safe migration routes, etc. But on the other hand, it could also be that some governments would want to use this technology to make it more difficult to migrate and make it more dangerous. So that's something that has to be debated and discussed. Climate anxiety and the like is already an issue, but will probably continue to increase. And AI is apparently also being used to some extent for monitoring anxiety and so on. I mentioned in part one how AI could be used to improve climate models, but maybe it can also be used to augment civilization models, such as World 3. Because, yeah, maybe there's ways in which we can have better predictions of general trends using also some sort of data-driven methods. So to summarize this part, my proposition is that collapse should be taken seriously and should be discussed in all parts of society, including us in the AI community, to avoid silos and singular viewpoints. Discussing this does not equate giving up. Rather, by facing this possible future, one has a better chance of adapting, preparing, and also avoiding panic responses. So we should consider how AI can be used to mitigate this, but also how it potentially can exacerbate it in some parts. And again, as I said in the beginning, this discussion does not mean we should give up efforts that align with optimistic scenarios, but rather accelerate that effort as well. So yeah, thanks.
I recently read a book. It's a fiction book by Jens Liljestrand. Even if everything ends, it sort of talks a little bit about, or it talks about scenario, which is really right about now. But it does talk about what you describe about the collapse, and it seems fairly plausible that we could come to a real crisis where we actually have not only people fleeing countries, but people fleeing regions within Sweden and so on.
Yeah. Well, what's the book called? Do you know?
Sorry, what?
You said it was a book, right?
Yes, it's called Even If Everything Ends in English. It's Även om allt tar slut in Swedish.
Thanks, I'll check it out.
He's a writer for Expressen, I think, otherwise a journalist.
Yeah.
So we have a comment in the chat here. There is a need for a Swedish arena on climate and AI, as suggested in the report AI in the Service of the Climate. Could RISE facilitate such an arena, for example, together with AI Sweden?
Yeah, I should certainly think and hope so. I mean, to begin with, I mean, RISE is a very interesting organization in the sense that RISE in itself contains a lot of different expertises. So that's something which I found great working here, is that because when you work with AI and climate, you need a lot of different expertises, and to have that in the same organization is very helpful. But as you ask for the Swedish arena, yeah, I mean, definitely I think RISE should be a player in that. Yes.
Another question in the chat. Do you see the opportunity to use AI machine learning to improve nuclear use and safety to address climate change?
Yeah, I mean, that's one of the things that's also mentioned in this Tackling Climate Change report. I think, I don't know what I think really. I think it's a very interesting thing to consider at least. But yeah, I don't know very specifically how that would work, but yeah, interesting idea.
Do we have some more questions or comments or ideas or anything for this discussion? what do you all think about the scenarios? And what do you think about the need for discussing the plan B here? Do you agree? Is it a good idea to discuss this, or should we just stick with the plan A?
Hi, this is Luis Sanchez from Rice Maritime. I am of the opinion that, that if we, I don't know, feels like keeping up with plan A is keeping up with plan B. Personally, even if everything goes to hell, then, for example, when it comes to biodiversity, trying to identify our increased biodiversity in Sweden, it helps in both cases, because even if things goes to hell, we need to keep on trying to protect that what is left.
Yeah, I agree.
Everything that you do for plan A will still be valid for plan B.
It's just the will to keep on going when you know that many of the things that you have grown up will not be experienced by your kids. I think that's the threshold for me when you realize that things have gone to hell. But still is keep on going and try to preserve as much as possible.
Yeah, I can relate to what you're saying.
I mean, a little bit related to that, there's some initiatives within RISE. They're called like SKIs. RISE gives funding for people to organize themselves in different groups. For example, AI at RISE got money for this. It's SVI. I can't remember what SVI stands for, but perhaps we could try to get. There's also a group that got also funding to create a biodiversity network. So perhaps we should try to do something similar. Try to get these groups of people all together in. Because you have the people that work with AI and with computers and data analysis, they have the knowledge, but the interesting questions are out there, and the people who knows these interesting questions might not be aware of the things that can be done with computers. So perhaps trying to get these groups of people together and discuss.
I can chip in, Sverker Jansson here. We have a large initiative called Samhällssäkerhet och beredskap, led by Tommy Hertzberg. So if you are interested in this general field, samhällsresilience and so on, please contact him. I know that he's very interested in reaching out to us and having sort of people commit some focus to the issues that they work on. I think part of sort of our reaction as an audience to your dark prophecies. No, it's not. I mean, it's but the scenarios is of course that. Yeah, that's sort of that sounds awful. I don't even want to think about it. It becomes so much. So I think to get to spur people to sort of think creatively, one may have to delimit it a bit and sort of focus on different parts and then say, okay, what about this part? What about this part? What about this part? And otherwise it feels really overwhelming, really. That was at least my reaction.
Yeah. Well, I can understand that definitely. And thanks for the advice on this resilience part on RISE. I'll check that out. So yeah, I mean, obviously it's, having this type of discussion in a half an hour is not really, it's difficult to do, but yeah, I just felt that at some point, having some sort of discussion around it would make sense, I find. But yeah, it's something which needs to be digested, that's for sure.
It was absolutely a good message to give, but still, I mean, I'm just trying to analyze my own and by extension maybe others' reaction, why there is sort of a compact silence that, ouch, what to do about this?
Yes, I understand, definitely.
But perhaps a couple constructive things is perhaps we should start talking more within RISE, and perhaps we should also create some initiative where RISE is just one part.
Yeah, And
discussion.
I agree, Olof. There could also be discussions about having, basically what you're saying, about having discussion groups and so on, which can discuss also these types of topics in some sense. I mean, maybe not everyone might not want to be part of that, but they could be interested in having more discussions on these, basically.
Do we have some last questions or comments? Otherwise, I think we'll conclude here and say welcome back next week. We'll have a visitor from KTH, Josephine Sullivan, who's an expert in computer vision, and she's the director of the master's program in machine learning. And so she'll give a talk same time next week. Welcome back, and thank you for today, and thank you especially Aleksis.
Thank you.